In this video, we're going to take a look at the questions on your Unit 7 review. So as you're working on the review activity, you're welcome to scroll through the video, find problems that you need help with, and use that to guide you. But if you try the problems on the review and feel successful in doing so, this test should be very easy for you. Looking at question A, we have 7xy to the 5/6 times negative 4x to the 1/3 y to the 1/2. So in keeping with our trend of exponent properties and simplifying, we need to keep it separate. So numbers go with numbers, x's with x's, y's with y's. So I'm going to start by multiplying my 7 and negative 4 to give me negative 28. The x's, as I multiply them together, I add them. So I'm going to add 1 plus 1/3. And the y's, I'm going to do the same thing, 5/6 plus 1/2. But then as I add the fractions together, I need to have a common denominator. So I'm going to make 1 a fraction by putting it over 1, and I'm going to multiply that by 3 over 3, which really means I'm adding 3 plus 1 over 3. So I'm going to keep that negative 28 in front, and the x's will be 4/3. For the second fraction, I need to have a denominator of 6, so I'm going to multiply the second fraction also by 3 over 3 to give me common denominator 6. And when I add 5 plus 3, I get y to the 8 over 6. That fraction I get to reduce though, so final answer is negative 28, x to the 4/3, and y to the 4/3. Moving on to question B, please don't be tempted to multiply your bases together. This should be a very quick question on the test, so please don't overcomplicate it. So I'm going to start by keeping my base of 5, but then I take my 7 and my 2 and I multiply them together. Once I do that, I get 5 to the 14th times 5 to the negative 6. But then when I combine them, I'm going to keep the base the same and add the exponents. 14 plus negative 6 is equal to 5 to the 8th. And you are welcome to keep that question at 5 to the 8th. You don't have to do anything else beyond that. Moving on to question C. We have a lot of stuff going on. So again, keep it numbers, P's, Q's, and then simplify it out. So I'm going to start with the top of the fraction. I'm going to start with the numerator, simplify it as much as I can, and then start moving things around. So 4 times 3 gives me 12. In total, there are 9 p's, p to the 7th times p squared, and there's 1 q. In the denominator, we still have 8, q to the 5th. So now I'm going to take my time and do numbers with numbers. 12 over 8 reduces to 3 over 2. They each have a 4 in common. There are no other p's, so that stays the same, p to the 9th. And then when I look at the q's, I have 1 on top and 5 on the bottom. So technically what I'm doing is q to the 1 minus 5, which is q to the negative 4, but I know I can't have any negative exponent, so I have to move it and lose it to the bottom. So final answer is 3p to the 9th over 2 q to the 4th. Question D, we have negative 3mn to the negative 5th, all to the 4th power. So that means that 4 as an exponent has to go to every single base inside the parentheses, including the negative 3. So this is going to be negative 3 to the 4th, and notice how I'm putting that in parentheses, m to the 4th, and then n to the negative 5 times 4, which is negative 20. And then I'm going to evaluate that number. Negative 3 to the 4th is positive 81. M to the 4th is going to stay. And again, I have to move it and lose it with my negative exponent, which is n to the 20th. For question E, now we're getting into simplifying with our radicals, but this definitely still includes some of our exponent properties as well. So when we take a look at E, we have cube root of 729 x to the 4th y to the 9th divided by cube root of 3x y to the 5th. So as I combine these two expressions, I'm going to make it one big radical. So 729 x to the 4th y to the 9th over 3x y to the 5th. So then I'm going to simplify it out and make it one radical. 729 divided by 3 gives me 243. I have 4 x's on top, 1 on the bottom, so that leaves me with x to the 3rd. 9 y's on top, 5 on the bottom. That leaves me with y to the 4th. And then I simplify it out from here. So 243 breaks down into 3 and 81. 81 is 3 and 27. 27 is 3 and 9. 9 is 3 and 3. So lots of stuff going on. My index for this one is 3. That means I need those groups of 3 to bring it out front. So 3 is going to come out front. And I have 2 3s left over. So I'm going to leave the cube root of 9 behind. And then when I go to my variables, I'm going to divide my exponent by the index. 3 goes into 3 one time with no leftovers. And 3 goes into 4 one time with 1 leftover. And that exponent on the y, that 1 I don't necessarily need, so I'll go ahead and get rid of it. But then that gives me my final answer. And finally, question F is very, very similar to question D, where I have to give that exponent to everything. So it's going to be 4 squared x to the 1/2 times 2, and then y to the 8th, which is 4 times 2. 4 squared is 16. 1/2 times 2 is just 1, so that I keep, and then it's y to the 8th. As we look at questions 2 and 3, those should be pretty much giveaway questions. Those are just converting between radical form and fractional exponent or rational exponent form. There's going to be one of each type. So one where you're going to make your radical look like a rational exponent and vice versa. So your goal is to make question 2 look like the problems in question 3, and then question 3 look like they do in the problems in question 2. So letter A, my job is to find my base, which is 2. The power is whatever is connected to that base, which is 5. My index is always the denominator. So final answer, 2 to the 5/3. Nothing else I have to do. On question B, my base is 3. I have an invisible power, which is 1, an invisible index, which is 2. So final answer, 3 to the 1/2. Question C, base is x, exponent is 4/5. Now moving on to question 3, I'm going the opposite way. So I know I'm going to need to have a radical in here, so I'm going to go ahead and draw that in. I'm going to put my base on the inside. Sometimes I like to draw this on a diagonal so I know that my x and my 6 are connected. So 6 stays inside the parentheses with the x, and my index is 7. B says 4 to the 9/2. This one, I'm going to put my radical. My base is 4. I'm going to take 4 to the 9th power, and I don't have to put the index because it is assumed to be 2. And finally, on question C, I have got a radical with base 5v. So notice how I'm putting that in parentheses in the radical. That's very important. My exponent is 11, and my index is 3. I might also see this one as the cube root of 5v to the 11th. So either way of writing that is the same. Moving on to question 5. I don't know why it skipped 4, but we're moving on to question 5. Now we're simplifying similar to what we did for the exponent property problem back in the top section. So on question A, we're doing a 4th root. So that means I need to have 4 things that match in order to bring something out front. So whatever that index is, that's what you're looking for. So I'm going to start with 176. And if I divide that out by 2, that gives me 88. So 2 and 88. 88 is 2 and 44. 44 is 2 and 22. 22 is 2 and 11. So if I'm looking for 4 things to match to bring something out front, these 2, all those 2s are what I'm going to bring out. So 2 comes to the front, and I have a 4th root of 11 left over. I'm going to divide my exponents by 4. 4 goes into 8 2 times, so m to the 2nd comes out with no leftovers. I do the ends. I divide by 4. 4 goes into 11, also 2 times, but this one leaves me with 3 leftovers. Same thing with letter B. My index is that invisible 2 in front. For 72, I'm going to pick 36 and 2. 36 is 6 and 6. So I don't need to break the 6's down anymore because I've already found a pair of numbers. and 1 that stays behind. So 6 is going to come to the front with root 2 left on the inside. I'm going to divide my exponents by 2. 2 goes into 9 4 times with 1 left over. Y has an invisible exponent of 1, and if I divide that by 2, 2 will never go into 1, so that is going to stay on the inside. For both questions C and D, my goal is to make this one big radical first before I do anything else. So as I look at question C, I'm going to keep this a cube root, but then I'm going to multiply the numbers on the inside and the variables on the inside as well. 27 times 3 is 81. I have p to the 7th because p to the 6th plus p to the 1st gives me 7. Q to the 3rd and r to the 4th. But now this problem looks just like it did in A and B, where all I have to do is simplify it out. So 81 breaks down into 9 and 9. 9 is 3 and 3, and 9 is 3 and 3. So I have a group of 3 things that matches and a 3 left behind. So 3 comes out front, cube root of 3 stays behind. I divide all of my exponents by 3. 3 goes into 7 2 times with 1 left over. 3 goes into 3 1 time with none left over. 3 goes into 4 1 time with 1 left over. And again, that's 1 I don't necessarily need. Same thing with question D, but notice these have values in front that we have to multiply as well. 2 times 3, it gives me 6. And then on the inside, I'm going to keep this one 25 times 20. And you'll see why here in a second. And then x to the 3rd and y. So if I multiply 25 by 20, I get 500. I'm going to have to break that down anyway, so I might as well keep it separate. 25 is 5 and 5. 20 is 5 and 4, and 4 is 2 and 2. So if I'm looking for groups of 2, because that's my index, the 5s match, the 2s match, and I have a leftover 5 in front. So if I take the 6 that's already there, the 5 I'm bringing out, and the 2 I'm bringing out, in front of my radical should be 60 with a 5 left over. And then I do my exponents the same way we have been. I'm going to divide by 2. 2 goes into 3 1 time with 1 left over. If I divide that invisible 1 by 2 on the y, no left or only 1 left over, none will come out front. So y will stay in. About our solving. So on 6a, I'm going to start by adding 9 on both sides so that I'm left with square root of 3k squared minus 15 equals 9. So then I get to square both sides. So I'm left with 3k squared minus 15 equals 81. And then my job is to get k by itself. So I'm going to start by adding 15 on both sides so that I have 3k squared equals 96. I'm going to divide by 3 so that I've got k squared equals 32. And then I am allowed to take square root of both sides. So notice this is combining the solving that we did in this unit with the solving that we've done before. So k is equal to plus or minus, because I'm taking a square root of whatever I get when I simplify 32. That breaks down into 16 and 2. 16 is 4 and 4. So 4 comes out, 2 stays behind. So plus or minus 4 root 2. This is one you have to check. So if you plug in either positive 4 root 2 or negative 4 root 2, when you square it and put it back into the original function, that's going to give you a positive value no matter what. So when you plug that back in, you get 32. 3 times 32 is 81. That's 96. 96 minus 15 is 81. Square root of 81 is 9, and 9 minus 9 is 0. That one is good to go. Question B, we're solving for k. So I'm going to start off by dividing by 2 on both sides. So I'm left with 3 equals square root of k plus 6. Then I'm allowed to square both sides so that I'm left with 9 equals k plus 6. I'm going to subtract 6 on both sides. So k is equal to 3. And again, this is an even root, so I need to plug it back in and check. 3 plus 6 is 9. Square root of 9 is 3, and 3 times 2 gives me 6, so that solution is also good to go. Moving on to question C, my goal is to get x by itself, so I'm going to subtract 11, so that I've got 3 equals cube root of x minus 5. I then get to cube both sides. So whatever the index is, that's the power that we raise both sides to. So that I'm left with 27 equals x minus 5. I add the 5. So x is equal to 32. And this one, because it was an odd root, I do not have to check. For question D, we are solving for x, so I'm going to start by subtracting the 1 on both sides. Again, my goal is to get the radical completely by itself, and then I can start moving things around. So I'm left with 2 times the 4th root of 2x plus 4 equals 4. I divide by the 2 in front, so that I am left with 4th root of 2x plus 4 equals 2. I then am going to raise both sides to the 4th power, so that I have 2x plus 4 equals 16. So as I start solving for x, and I got that 16, notice 2 to the 4th is 16 and not 8. So I'm going to subtract 4. And if 2x equals 12, then x is equal to 6 when I divide. This is an even root, so I do have to substitute it back into check. 6 times 2 is 12. 12 plus 4 is 16. The 4th root of 16 is 2. 2 times 2 is 4, and 4 plus 1 does give me 5. Moving on to questions E and F, we're going to have some foiling and factoring that we have to do for these as well. And we also have to start checking for those extraneous solutions. So on question E, I'm going to start by squaring both sides, so that I have 2x minus 7 equals x minus 5 times x minus 5. Notice how I wrote that twice. So the left side, I'm going to keep for now 2x minus 7. On the right side, I'm going to FOIL that out. So I've got x squared minus 5x plus 25. So do your box method, do your arrows, do whatever you need to get everything on the same side. So then I need to move my 2x and my 7 to get everything on the same side, so that I'm left with 0 equals x squared minus 12x plus 32. So I'm looking for numbers that multiply to be 32, add to be negative 12. Those numbers are negative 8 and negative 4, which tells me that x is equal to positive 8 and positive 4. So this is where I have to start checking, does my equation make sense? Because I have to see those extraneous solutions. So if I plug in 8, 8 times 2 is 16. 16 minus 7 is 9. So my goal is, does the square root of 9 equal 8 minus 5? 8 minus 5 is positive 3. And root 9 is 3. So that works out. I need to do the same thing for 4. So if I plug in 4, 2 times 4 is 8, minus 7 is 1. So I need to check, does the square root of 1 equal the right side? And if I plug in 4 minus 5, that gives me negative 1. Square root of 1 does not equal negative 1. That is my extraneous solution. So the only one that gets to count is the 8. For question F, I started off with adding the 4 on both sides. My goal, again, is to isolate the radical, so that I'm left with square root of 6r plus 15 equals r plus 4. I then get to raise both sides to the second power, so that I've got 6r plus 15 equals r squared plus 8r plus 16. So I save myself a little bit of space and I just multiply it out for us. But again, write it twice, FOIL, do all that you need to do. I'm going to get it equal to 0 by moving over our like terms. So 0 equals r squared plus 2r plus 1. So this factors into r plus 1, r plus 1. When I write my solution, I only need to include it once, but I still do have to check and see that it works. So I'm going to plug that -1 in for r. So I've got -4 plus 6 times -1 is -6 plus 15 is 9. So I'm going to see, does -4 plus root 9 equal -1? Root 9 is 3, and -4 plus 3 does give me -1. So that solution is good to go. All right, we're going to start taking a look at our last 4 solving questions for the review. On question G, under no circumstance would you be allowed to distribute the 3. Instead, we're going to divide both sides by 3 so that we've got 28x minus 3 to the 3/2 power equals 729. So now that the parentheses are by themselves, I'm going to raise both sides to the reciprocal power, which is 2/3. On the left side, I'm going to be left with 28x minus 3. And on the right side, I'm going to type into my calculator 729 to the 2/3. That gives me 81. I'm going to add 3 on both sides so that 28x equals 84. And when I divide both sides by 28, x is equal to 3. Because when we took the reciprocal power, the numerator is even. That means I need to check my answer. So when I plug in 3, 3 times 28 is 84. 84 minus 3 is 81. When I take 81 to the 3/2 power and multiply that by the 3 in front, I do get 2187, so we're good to go there. For question H, I'm going to start by adding 7 on both sides so that I have 75 equals 3x to the 2/3 power. I then divide both sides by 3 so that I'm left with 25 equals x to the 3/2. Now that my x, or my parentheses, is by itself, I'm going to raise both sides to the reciprocal power, which is, and I wrote that wrong, so let me change that real quick. So this, I put a 3/2, that should actually be a 2/3, so let me go back and fix that. So again, original problem, 2/3. So then when we raise it to the reciprocal power, we're going to raise it to the 3/2. So on the left side, 25 to the 3/2 power gives me 125. And on the right side, I've got just x. But because, let's notice, the denominator, when I took the reciprocal, is even, that means I need to add plus or minus in front. Moving on to question I, my first step is going to be to subtract 10 on both sides. So then I'm left with -64 equals -x minus 1 to the 3/2 power. I'm going to divide by -1 on both sides to clear out that negative in front. Again, you are not allowed to distribute it. That exponent stops you from doing so. So on the left, I've got 64 equals x minus 1 to the 3/2. And now I get to take both sides to the reciprocal power, which is 2/3. 64 to the 2/3 power is equal to 16. So if I've got 16 equals x minus 1, I add the 1. So x is equal to 17. Again, this was even in the numerator, so I do have to check my work. So inside the parentheses, I want to do like the entire right side, see if it's equal to -54. So in the parentheses, 17 minus 1 is 16. 16 to the 3/2 is 64. And then when I take 10 minus 64, I do get -54. Last one for the solving section, I'm going to start by adding 1 on both sides so that I've got 2 times 2x plus 4 to the 4/3 equals 32. I'm then going to divide both sides by 2 so that I've got 2x plus 4 to the 4/3 equals 16. I then get to raise both sides to the reciprocal power, which is 3/4. On the left side, I've got 2x plus 4. On the right side, because our denominator was even when we found that reciprocal power, I do need plus or minus, and it should be plus or minus 8. 16 to the 3/4 is equal to 8. So then I'm going to separate it out into two separate equations, where 2x plus 4 equals positive 8, and where 2x plus 4 equals negative 8. So in the first one, subtracting 4, dividing by 2. So first solution is positive 2. In the second one, I subtract the 4, divide by the 2, and get my two solutions. So even though we need the plus or minus, it is good news because I don't have to check though, because denominator is the even part, not the numerator. Last question. So taking a look at A and B, we're looking at key features of those graphs. So the first one is our cube root function. The second one is our square root function. So we learned that cube root functions are pretty much continuous throughout their entire domain and range, and they either only do increasing or decreasing. So cube root graph's not super interesting. We have more to talk about for the square root. So on question A, our domain, that's all of our possible x values, is negative infinity to positive infinity. Range is also negative infinity to positive infinity, and that describes the y values. When we look at increasing, we read that from left to right, and we're describing what the x values do. So if I start at the very left side and I track my x values, they're doing nothing but increasing. So they are going to increase forever from negative infinity to infinity and will never decrease. For end behavior, I need to write in my two little sentence starters, which are as x approaches infinity, y approaches blank. And as x approaches negative infinity, y approaches blank. So the top one means, what is the right side of my function doing? So as my x's get bigger, my y's are also getting bigger. So those are going to positive infinity. For the next one, that means as my x's get smaller, what's happening to my y's? They are also getting smaller to negative infinity. Now when we get to the radical function, the square root one specifically, let's notice this left side is basically just a dot, where the right side is the arrow. So we are starting somewhere, continuing and off in only one direction. So when we look at domain and all the possible x values, our function starts at 1 and then goes to positive infinity. And 1 gets a bracket because it's a point on our graph that actually exists. The range, so from bottom to top, starts at negative infinity and goes to 0. So this is the highest possible point, which is 0. Our function is never increasing. It is only ever decreasing from 1 to infinity. And finally, end behavior. This is where we have to change it a little bit because we have a function with a restricted domain. It does not exist past positive 1, so we have to account for that. So right side is still good because that's still an arrow. So as x approaches infinity, y approaches blank. But for the left side, we're going to say as x approaches 1, because our function will never cross 1, y approaches blank. So for the top one, the right side, that is heading down to negative infinity as my x's get bigger. And as x approaches 1, so that's the left side, our y values approach 0.